I'm not sure why I formatted it this way with this big space on the right, but maybe it's just so you have room to draw a grid. Rotation angle A has the following properties. The terminal arm lies in quadrant 3, and the reference angle is 50 degrees. You're told that A is between 0 and 360 because if I said, what is the value of A, there are an infinite number of rotation angles that will land you in quadrant 3 with a reference angle of 50 degrees. However, you ought to be able to figure out that if this is 50 degrees, that the rotation angle A is 230 degrees. How is my arithmetic there? I have to take 180 degrees and I have to add that 50 to give me 230. You see where I'm getting the 230 from? So angle A in degrees is 230 degrees. On the other hand, we have a different rotation angle B, and it terminates in quadrant 2 with a reference angle of 75 degrees. So this is 75 degrees, and that means that this is angle B. And again, you're told here, Melanie, that A, oh, this should say B. Does yours say A? It should say B. You're told that the angle is, again, between 0 and 360. So it's pretty easy to figure out based on that diagram that I just gave you that it will be 105 degrees, 180 minus 75, 105 degrees. So angle B is 105 degrees. Now, that part of the question, just getting to this point where we know what angle A and angle B are in degrees, is really a Math 20 question. So we have to do all this preliminary Math 20 work before we can get to the Math 30. The value of A minus B is m pi over 36. So there's no degree symbol on this, right? If there's no degree symbol on something, then you know it's radians. I think if I put this on an exam, I would probably say the value of A minus B in radians is, I think I would add that, but I don't need to. So I guess what we can do is we can take A minus B and see what we get in degrees, and then we have to convert it to radians. So what is A minus B? A minus B will be 230 degrees minus 105 degrees, which by my count gives me 115 degrees. And verify that for me. Thank you. 125, right, 125 degrees. And now what we need to do is convert that, Melanie, to radians. And by the way, you know, I do that in my head and I forget a 10 somewhere. If I were writing an exam, I wouldn't be doing anything in my head. I would be double checking, unless it's really obvious. And you know, I'm being honest with you here. As I get older, sometimes my brain doesn't operate the way I want it to. That's probably true 25 years ago for me as well. Your brain is not always cooperating. So 125 degrees, what we can do here now is say x over 125 degrees equals pi radians over 180 degrees, and cross multiply and solve. So we're going to get for x 125 pi over 180, and I want to say that that's 25 pi over 36. I think 125 over 180 reduces to 25 over 36. Does that help, Melanie? Okay, other questions? Go ahead. 53? So I haven't gone through last semester's exam or last year's exams and decided which questions to remove to bring it down to a smaller total for this year. But off the top of my head, I would say that there will be some graphing stuff on the exam. At least one question where we don't care about C. I want to know if you can determine the period from a graph and find the value of B. I want to test your understanding of maybe the connection between A and D and the range of a graph. But there will also be something where you will need to find C. And I believe this is going to be one where we need to find C. Looking at this, if you want, and I'll provide you with rulers on Monday. Sometimes it's nice to have a ruler so you can draw these things. You can draw those guidelines, whatever you would like to call them, to help you decipher what's going on. So I like to, if I were doing this as a student, I would recommend writing y equals 30 on that line and y equals 22 on that line, and then I can see very clearly that the difference between them is 8. I think sometimes if you're looking here at these ordered pairs, I think you might mix up your x's and y's sometimes. So I've just extracted the y's, and I've determined that this distance from here to here, which is 2 times the amplitude, is 8, which means the amplitude is 4, which means I can get away with saying A equals 4. Okay. What's interesting about this question is, unlike anything else we've looked at, you're not given any direction in terms of whether A is positive or negative. You're not told whether it's a cosine or a sine function. But it doesn't matter which function you choose. If the equation is right, it will have the right y-intercept. In other words, I can create an equation of a sine function with a negative 4 in front, or a sine function with a positive 4 in front, or a cosine with negative, or a cosine with positive. They'll all have different shifts. Well, there might be a coincidental equaling of shifts, but they'll in general have different shifts, but because of the reflections and where the start points are, they will all look the same. They will all match this. From this is the way my mind operates. I know that the middle of this graph is the location of D. And personally, I would just, I'll just leave it there. Personally, I would just use the amplitude and what I have written off on the side, and I would take 30 minus 4 to get 26. And then I would double check and see if when I add 4 to 22, I get 26. You could, I know that some people might want to do this. I just shy away from it. You could add the maximum and minimum and divide by 2. That would work. Anyway, that's telling you that D is 26. Additionally, we need to find B, and I'm just going to put this off on the side. My thinking here is that B is 2 pi over the period. So I need to go up here and decipher this graph in terms of the period. And what I'm going to focus my attention on is from here to here. And I just have to put that curve and then erase it, otherwise my program draws a straight line. Okay, so that's what I'm going to focus my attention on. But you should be aware, and I think it's obvious, that's not a full period. That's half of a period. And it goes from x equals 80 to x equals 94, which means there's a total horizontal distance there of 14. Well, if that distance from here to here is 14, the period is 28. This is a long, involved question, by the way, right? It's not a simple question. And that means that B will have a value of 2 pi over the period we've determined, which is 28. So B has a value of pi over 14. So now comes the tough part, right? Finding C. I don't believe there are too many people around that can draw. What do you want to use, sine or cosine? Sine? Okay, so we're going to go with a sine function. I don't believe there are too many people that could draw the sine function with these parameters and C equals 0 on top of this and then look at it and say, what's the shift? I don't know, maybe I'm missing something. Maybe that's a part of my brain that never developed, but I don't think so. I think it's complicated. It's different if you have a grid line and you can count squares and that kind of thing. So we're going to have to use the missing parameter approach, which will mean we write out the equation. And are you fine with using a positive 4? Okay. Write out the equation, 4 sine, and then I'm going to put b, which is pi over 14, and then brackets x minus c, n bracket plus d, which is 26. So a goes in there, b goes in here, c we don't know, and d is 26. I would resist the temptation, even though you probably know what you're going to do next, which is to put in an x and a y. I would resist the temptation to put in x and y at the same time as you put in a, b, and d. There's too many numbers to sort out. Okay. So which point are we going to use? Well, based on my conversation with you before we started this today, even though you don't know the coordinates of a middle point, never choose a middle point because you're rolling the dice on whether it's going to be correct or not. Okay? So we can choose 80, 30 or 94, 22. It doesn't matter. Do you have a preference? Okay, so let's use the top point of 80, 30. What that means is that I am going to put in $30 here and 80 here. Even that, you just have to slow down and be organized. I would, if I were rushing or my head wasn't screwed on straight in a particular point in time, I might mix those up. It's very easy to mix them up. There's a lot of numbers going on here. So y is the second number, which is 30. I'm going to put 30 here. This is equal to 4 times sine of pi over 14 times x, which is 80, and then plus 26. Now, since, we'll double check that, y is 30, x is 80, yep, 4, okay, we're okay. Since I've chosen a maximum, well, I want to say since I've chosen a maximum, I'm going to get positive 1. That's only true if a is positive as well. If a happens to be negative, then I would get a negative 1 when I rearrange. But when I take this 30 and subtract the 26 from the other side, that gives me 4. And when I divide by this 4, I get 1. And I think, you know, if there's ever a time to cut a few corners, it's right here. You're already doing so much work. Are you going to write minus 26 and rewrite the whole thing, divided by 4, and rewrite the whole thing? I think it's okay to take a shortcut here. So we get 1 equals sine of pi over 14 times 80 minus c, n bracket plus 26. Nope, not plus 26. We've already taken care of that. I apologize, and you know I do this sometimes. Let's just look at why I'm doing what I'm doing. You need to know the y-intercept of the function. That's what the question is. The only way you can know the y-intercept of the function is if you can determine the function. You're not going to try to put a grid someplace on here way back at 0 for x and 0 for y and try to figure out where the y-intercept will be. That's not going to work. So this is why we're doing all of this. So now what you do, and I like this idea of saying this is just too complicated to think about for some people, is you simplify this to something that, I mean, if you want, put theta here. I don't care. Change it from sine of that mess to sine of theta equals 1. And you should know that if this is true, theta equals pi over 2. Without a doubt. I mean, could it be negative 3 pi over 2? Yes. But from 0 to 2 pi is what I would confine myself to here. And there's only one point where sine is equal to 1, because the y-coordinate is equal to 1 at the top. What that means is that these things are all the same. Right? The angle that you take the sine of to get 1 is pi over 2. That means this, quote, angle, of pi over 14 times 80 minus c has to be equal to pi over 2. It has to be, because sine of it is 1. That's a logical leap that's confusing. It can be confusing. And I think if you change it to sine of theta equals 1 and just think of theta first, that might help. I can divide both sides by pi. I can multiply both sides by 14 and get 80 minus c is equal to 7. And then when I add c to the other side to make it positive and subtract the 7, I get 73 equals c. 80 minus 7 is 73, is it not? Okay. And now what I've determined is the equation of the function. I have y equals a, which is 4, times sine of b, which is pi over 14, times x minus c, which is 73, plus 26. So just, you have stuff written down here. Can you confirm that a is 4, b is pi over 14, d was 26, and we've determined c is 73. So I wouldn't mess around here. If you want to find a y-intercept, I think it's best just to put this function in for y and either look at the graph or, I mean, we could do this. Why don't we do this? Let's make sure we're in radian mode first. You don't have to look at the graph here. You certainly can. But from your home screen, you can just calculate what the y-coordinate is when x is 0 in radian mode, because of that pi over 14. So 4 sine, boy, you know what? Do you remember yesterday, Lucas, you and I were, or the day before, we were looking at all those brackets? It can be confusing. I might figure out what this is first. I might do it in pieces. I might go, 0 minus 73, and then I'm going to go times pi divided by 14. And then I'm going to take, and don't look at this and try to connect this somehow to a circle or a rotation or anything. It's just an equation. That is what we're going to take the sine of. And now I have to multiply by 4, and I have to add 26. So is the answer to this question 28.5? Okay. If you as a student are getting nervous at this point with this kind of question, it might ease your mind to know that I get nervous at this point. There's just so many steps. This is a kind of question, and I just want to be honest with you, that Alberta Ed would put on a diploma exam knowing full well that only 30% of the province will get it right. We do better than the province usually. 60% would get it right. I'm saying that most of you should be able to get this question right, and some of you will not get it right. It's just that separating the wheat from the chaff, if you're familiar with that expression. I don't mean to compare you to grains or anything like that, but you get my drift, right? Okay. By the way, and we're not going to do this, well, we will. I have a feeling we have time. We could put this into our calculator. This is complicated, and again, when you have your calculator in that mode where you type and things go off the screen, it's a real disadvantage here, because you want to check your brackets and you scroll here to check the end brackets and you're missing the ones at the front, and you scroll back and you're missing the ones at the end. That's why I always prefer this mode. So I have sine of bracket pi over 14 bracket x minus 73. I close the brackets on the x minus 73. I close the brackets on the argument of the sine, and then I go plus 26. And this is maybe leading up to the next unit. Zoom trig is a waste of time. Zoom trig will go from 0 to 2 pi, or negative 2 pi to 2 pi. Well, 2 pi is like 6.28. It's gonna focus in on a little part of the graph here. And it also goes from negative 4 to 4. Use these numbers as a guide. So if I want to see, I'm just going to make sure I'm in radians. I'm going to go to window. If I want to see these features of the graph, this x-coordinate is 80, this x-coordinate is 94, maybe I should go from, 70 to 120 to include those numbers. What am I looking at here? Well, the minimum y is 22, the maximum is 30. Maybe I'll go from, 20 to 32 would do it. I could look a little bit further. If you don't manually change those settings, you don't know where to look. And the reason why we're looking is we want to confirm that if I go trace 80, I get 30. And if I go trace 94, I get 22. It's a pretty deep question. There's a lot to it. Other questions? Go ahead, Melanie. 51? Trigonometric ratios can have all kinds of different values. Sine can be anything. Sine of an angle can be anything from -1 up to and including 1 and anything in between. Cosine, the same thing. They can sometimes be equal to the number 1 for a variety of reasons. Sine of theta can be equal to 1 because that's the top of sine of theta on a graph. Or on the unit circle, there is a point where y equals 1. But things like, say, tangent will be equal to 1 at those 45-degree reference positions in quadrant 1 and quadrant 3 because x and y are equal in those two locations. Root 2 over 2, comma, root 2 over 2. And in quadrant 3, negative root 2 over 2, comma, negative root 2 over 2. And tangent's y over x, so when you divide them, you get 1. So, and it could be the case as well that reciprocal trigonometric ratios can be 1 for a variety of reasons. Cotangent would be 1 in these two locations as well. But cosecant would be 1, and I'm not saying cosecant is 1 here. Cosecant can be 1. Let's think about this. Cosecant is the reciprocal of sine. Right here at the top of your unit circle, sine is equal to 1. So cosecant of pi over 2 is 1. Right? On the other hand, so I'm getting to the question. On the other hand, as well as trig ratios being all kinds of weird decimal values, they can take on values of 1, and they can also take on values of 0. So for example, and I'm not saying this is the case here, but tangent can be 0 in these two locations because tangent is y over x, and in these two locations at 0 and pi, y is 0. Right? So trigonometric ratios can be 0. Trigonometric ratios can also be undefined because if a trig ratio can be 0, then the reciprocal of that is not defined. So for example, what is the value of cos of theta at pi over 2? What is the value of cosine of pi over 2? It's 0. So what is the value of secant of pi over 2? Well, it's the reciprocal of 0. You can't do that. It's not defined. Okay? So this is the idea. When we take a look now at this point for the tangent, we know that tangent is y over x. Oh, wait, but at that point on the unit circle, x is 0. So tan of pi over 2 will not be defined because you can't divide by 0. Now, of course, if you go tan of pi over 2 in radian mode, you'll get an error. But as a student, I think you might look at that and go, why am I getting an error? Is it because it's undefined or did I do something wrong? So this one is undefined, which means we put the number 2 here. You understand how the key works? Okay. What about cotangent of 3 pi over 2? Well, 3 pi over 2 is here. And what are the coordinates here? Because we're going to need them. This will be 0, comma, negative 1. Cotangent, this was y over x. Cotangent is x over y. So that would mean we would have at this point 0 over negative 1. That's allowed. You are allowed to divide 0 by non-zero numbers. 0 over a non-zero number is 0. Other way around is not defined. So this will be equal to cotangent will be equal to 0, which is number 1. And I admit this kind of question with the 1s and 2s is confusing because the 1 doesn't actually mean it's equal to 1. It means it's equal to 0. Right? If you go to sine of pi, well, that's this location. And you should know that sine is the y coordinate. We can say y over r, but if we use the unit circle, it makes it easier. And the y coordinate over here is 0, so that trigonometric ratio is 0, which means this is a 1. And cosecant of 2 pi, well, 2 pi is here. Cosecant on the unit circle is the reciprocal of y. I could go r over y and just use any r I want. But it's 1 over y. Y is 0 at this point. The reciprocal of 0 is undefined. So the answer is, 2112. Good album. It is. Check it out. Other questions? There's 2 ways to do this. This is one of these cases where you can't just do something to the question and get the answer. You have to inspect all 4 of the answers, okay, one way or another. And the maximum value of a function with these properties of a, b, c, and d, and sine and cosine will always be the value of d plus the amplitude. Because if d is at, for example, d over here is at negative 5, and the amplitude is 6, then we need to have a maximum that's 6 above that negative 5 and a maximum that's 6 below that. So if this is d, this is y equals d, which is negative 5. Do you see, do you see based on the equation up here in the question, the amplitude is 6? Okay. So that means that this will be at 1. Negative 5 plus 1. So now what we need to do is run through these choices and see which one of them would also give us a maximum value of 1. So for example, negative 5 has the same d, right? The amplitude is only 4. That's not going to take us to 1. Yeah? Okay, I'll be there in a minute. This is at negative 4, which is here, and the amplitude is 5. Instead of 6, so you still end up at 1. Does that make sense? Okay, you sure? Yeah.
Could you do number 13, please?
13? Absolutely. So we want to know the exact value. We want to know the exact value of negative 14 pi over 3. Your starting point is to locate that point on the terminal arm at negative 14 pi over 3. Are you with me? Now pi over 3, I'll put on here lines that separate this circle into pi over 3s, right? They're 60-degree chunks. This should maybe be over there just a little bit, but it doesn't matter. So negative 14 means we start here and go clockwise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's that point. And you're asked for the value of cosecant. And we'll get back to that in a second, but let me write out what the coordinates are here. Would you agree those are the coordinates of that point on the unit circle? And would you further agree that cosecant of theta is r over y? And on the unit circle, it's 1 over y. Or would you agree that cosecant is the reciprocal of sine? So we have to flip that over. Now, unfortunately, we get negative 2 over root 3, which does not mesh with that. But if we use Math 10 and rationalize this, we get the answer. Good? How are you doing, Faye? Okay. You doing okay? Yeah. How are you doing?
I don't understand 5 on here.
Okay.
Because I'm going through there.
It's the same kind of thing we were just doing here. So we want to know the exact value of sine of negative pi over 6. On the unit circle, well, maybe I will start off by saying this, Noel. Both of these angles are angles that we have knowledge of precisely where they are on the unit circle. Negative pi over 6 is here, with coordinates of root 3 over 2, comma, negative 1/2. 7 pi over 4. Pi over 4 is 45 degrees. So 1, 2, 3, 4, 5, 6, 7. 7 pi over 4 is here. And that has coordinates of, now, just before we go on, we are going to be adding these things together, right? And when you look at the answer, we have a common denominator of 2. We could put this, but then we're going to have roots in the bottom, and it would be better looking ahead to use root 2 over 2, comma, negative root 2 over 2. And sine, so now this is that. It's the y coordinate. This is this. It's the x coordinate. So we need to add those two. You're going to get negative 1 over 2 plus root 2 over 2, which is negative 1 plus root 2 over 2. Now, the order on the top has been flipped, so we would write this as root 2 minus 1 over 2. Are you okay with that? Okay, good. Yeah. 7? Yeah. So we are asked to determine two things. We're asked to determine theta, first of all, and what arc length are we? The value.
To give us the radius. We need the radius. And,
Oh, I see.
yeah.
So this should say radius.
Yeah.
Okay. I hope the radius is there. We're going to find out. So how is it we can find theta? Well, we know that a full revolution is 2 pi. And that means that 17 pi over 12 plus theta has to be 2 pi, or theta has to be 2 pi minus 17 pi over 12. Well, I'm just going to make a common denominator here of 12 by multiplying the top and the bottom of 2 pi by 12 to get 24 pi over 12. So you subtract these and you get 7 pi over 12. So it's not A, it's not C. Now what's the radius? In order to find the radius, we have to use the arc length formula. And I hope it's obvious when we have theta, we have theta equals A over R, and I apologize that A is arc length and it should say R in the question. I hope it's obvious that if you're going to use this angle, you have to use this arc length, which is leading us nowhere because we don't know that arc length. So I'm going to use this as the arc length. Nope. I'm going to use this as the arc length. It's deceiving, isn't it? Because they're both kind of drawn like this, but this as the angle. So I put in 17 pi over 12. This is equal to the arc length of 68 pi over the radius. So we have to find the radius. The pi's cancel, a little bit of cross multiplication magic gives us R equals whatever 68 times 12 divided by 17 is, and I think that's 48. I think 68 over 17 is 4. 4 times 12 is 48. So I'm getting a radius of 48. So those of you that may not have been listening here, and that's not a criticism, this question 7 should have an R on that heading, not an A.
Why? So when I tried to find the ratio, so first you do times the overhead one?
So the point, negative 1/2 comma root 3 over 2, is here. Correct? Okay. So we want to subtract from that 5 pi over 3. And this is the one case, Joanna, where I would think in degrees. Okay, I mean this is 120 degrees. That's what theta is. And we want to subtract 5 pi over 3. That's 5 times 60 degrees. So we want to subtract 300 degrees. And I get negative 180. So the angle that we get is negative 180 degrees, and that will intersect the unit circle at this point, which is at negative 1 comma 0. Does that make sense? Okay. I think looking at this and saying I want to take away 5 pi over 3, that works as well, but it's harder on the brain. You take away 1, 2, 3, 4, 5 pi over 3. Are good? Okay. So I'm just going to take a look at number 44 here if you're interested. I know the bell's going to ring, but can you try to keep it down a little bit while I just explain this quickly? First of all, we know the terminal arm lies someplace. We'll get to where it lies, but the rotation angle that takes us there is between 0 and 360. Okay? This is a case of what looks to be a complicated problem or a problem with a complicated solution, but the solution is a simple one. And the key is that you need to know for the exam, you will be tested on this somewhere, that a point on the unit circle will always pass through cos of theta, comma, sine of theta. And, so that's not really for this question, but I want to put it here anyway. And the x coordinate squared plus the y coordinate squared will give you 1. Okay. Now, when you take a look at this question, and we can only do this because it says it intersects the unit circle. Tangent is y over x. Now, you're told that tangent is positive. Since x of that point is negative, y must be negative as well. So what we need to do is this. And you need to take 1 minus, in brackets, negative 0.57 squared, and then tell me what you get before you square root it.
0.6751.
Okay, so about 0.675. Now, we would normally put plus or minus here, but we've already figured out that it must be negative. Once you find that value, then you simply have to divide it by x to get tangent of theta, because that's y, and tangent is y over x. Does that make sense? Have a great rest of the day and a great weekend, you guys. We'll talk to you later.